the result is in the smallest digit in the question, you have to bring your answer to the decimal place, whichever least in your question. The denominator number is going to the numerator side. That time the plus 4 is get converted into -4. You will be having various decimal places. Which is the smallest decimal place? Your result should bring to that smallest digital or decimal place. Hello everyone, this is Harshita Bhavasar from Vidhyaashram School of Excellence. Today we shall start up the session 2 from the chapter Some Basic Concepts of Chemistry. In the last session we have discussed about introduction of chemistry, important scope of chemistry and matter, mixture, pure substances, overall units of measurement. We have seen basic physical quantities, what are its SI units, everything. How the elements and compounds will be different, mixture and compounds, pure substance, everything we have discussed with its definition and various kinds of examples in the previous session. In this session, we will discuss about mass and weight, volume, density, temperature, scientific notation, precision versus accuracy and significant figures. Half of it all are about physical quantities. How to do the problems? If you want to do the problems, you have the knowledge of scientific notation. If you want to know what is correct and what is wrong, you have the knowledge of precision versus accuracy. How to wind up with the result? For that, you should have the significant figures. We'll see one by one. That is mass and weight. Everyone will think both are same, but no. What is mass? It is the amount of matter present in it. The mass of a substance is always constant. If you write any element, you will get always same atomic weight, atomic mass. Why it will get same atomic mass? Because we are seeing the content present in the element. It will not change. It is always constant. If you see hydrogen, it will get 1.008 only the atomic mass. If you see sodium, you will get 23 only all the time. That is mass. It will always constant. The whatever you are recognizing, the amount of matter present in it. Then what is weight? It is a force exerted by gravity on object. It may vary from place to place due to change in gravity. You know about gravitational force and we have the knowledge that the gravitational force is always varied from one place to another place. If the force exerted by the gravity on object is weight, then gravity will be changed from one place to another place. Then weight will always a variable. It is not a constant thing, right? That means mass is a constant and weight is a force exerted by gravity, which is a variable. This is about mass and weight. Next is volume. It means the space occupied by matter. When we will see or we will look for the volume in the liquid. We know that liquid having the freedom of movement and it doesn't have shape, but it is having just a volume. It occupies the container placed for it. So it will, what it will do? It will occupy the space by the matter. And for the volumetric analysis, you have various kinds of measurable things, okay, that is burette, graduated cylinder, pipette and volumetric flask. If you want to take the accurate measurement of volume of liquid or solutions, you want to use this apparatus, okay. See here burette, it is having 50 ml burette, we are having 25 ml burette, 10 ml burette, everything. Same thing graduated cylinder. It is not an accurate thing, it is a precise measurement it will show. But pipette, volumetric flask and burette will show accurate measurement of any volume. And this is pipette and this is volumetric flask. If you put any solution till the mark, that mark will called meniscus, you will get the accurate level how much you want. If it is 100 ml, you should not pour the solutions till the neck, only till the mark. Okay. In pipette also it is having 1 mark. Till that only you should pour. Next is density. It is defined the amount of mass per unit volume. We know that from the so many classes, density is nothing but mass by volume, nothing but m by v, right? Next, temperature. If you want to measure the temperature, that is degree of hotness. Temperature is nothing but degree of hotness. That degree of hotness, if you want to measure, there are various kinds of scales, that is Celsius, Kelvin and Fahrenheit. There are 3 scales in which temperature can be measured. These are known as Celsius scale, which will be represented by degree Celsius, Fahrenheit, degree F and Kelvin K. Thermometers with Celsius scale are calibrated from 0 degree to 100 degree Celsius. Thermometers with Fahrenheit scale are calibrated from 32 degree Fahrenheit to 212 degree Fahrenheit. And Kelvin, 0 Kelvin to 273.15 Kelvin. These are the scales, Kelvin, Celsius and Fahrenheit. Okay, with the different ranges. Next, Kelvin scale of temperature of SI scale and is very common these days. The temperature on 2 scales are related to each thereby the relationship, that is degree Fahrenheit equals to 9 by 5 degree Celsius plus 32. If you have a temperature with respect to degree Celsius, if you want to convert it for degree Fahrenheit, you can use this formula. Whatever you are getting like 60 degree, right? If you have the 60 degree Celsius, if you put here 9 by 5 into 60 plus 32, whatever the result you will get, that will be around on the terms of Fahrenheit. The Kelvin scale is related to Celsius scale as follows, that is Kelvin equals to degree Celsius plus 273.15. Next is scientific notation. It is the way of writing numbers that are too large or too small to be convenient written in standard decimal notations. See, various scientists have done the various observations or experiments. At that time, they were getting too large numbers or too small numbers. Means very small or very large numbers. At that time, they cannot count those numbers of zeros only. Okay. It was a difficulty to handle those large numbers or very small numbers. That time only, they took this scientific notation. A chemist has to deal with numbers as large as, see here, 602, 200, how many zeros are there to get 2 gram of hydrogen gas, or small as 0 to here till 0, 166 mass of hydrogen atom. This many large number was there for only 2 gram of hydrogen. That time, so many scientists have proposed the scientific notation. N into 10 to the power of n or n into 10 to the power of x. This n can be 0 to 9.99 but not 10. Okay. And this x can be positive or negative. It can anything. Like if you want to 0.87 into 10 to the power minus 3 or 96.25 into 10 to the power 4. If only 4 we have written means it is in a positive way. Next is, this problem is solved by using scientific notation for such numbers, that is exponential notation, in which any number can be represented in the form of n into 10 to the power of n, where n is exponent and having positive as negative values and big N is number called digit term, which varies between 1 to 9.999. This is nothing but n. This is 10 into the power n. We know this n can be 1 to 9.99 like that, and this 10 to the power of 10 is a base, and this n can be exponent, that is negative or it may be positive also. And how to convert scientific notation? See here, if you are having 1484.268, If you want to convert, see how to convert, you have to notice the decimal. This decimal is moving towards the left side. How many times it is moving? 3 times. Means 1.484268 into 10 to the power of 3. If it is the point is moving towards left, this sign will be having positive sign. Another example, see here, 1, 2, 3, 4, 5. This decimal is moving. After 5 places, it will get here 10 to the power of 5 with a positive sign. If the decimal is moving towards the left, then positive sign. If the decimal is moving towards 1, 2, 3 like that, it will get 1.6 into 10 to the power of minus. See here, 1, 2, 3, 4, 5. Right? Minus 5, you will get negative sign. If it is moving to point left, positive. If it is moving to right, negative. You have to notice where the digit going towards right or left. This is the way to convert scientific notation. And the calculation of scientific notation, you have multiplication, subtraction, division and addition. First we will see the multiplication and division. See here, 5.6 into 10 to the power of 5 into 6.9 into 10 to the power of 8. What they are doing? 5.6 into 6.9, first they will multiply and 5 plus 8 they will add. Okay, they will get 10 to the power 13 and everything. Here they are moving right side, so it is in positive sign and it is increased by 1 number. See here, 9.8 into 10 to the power of, similarly another problem, 9.8 into 10 to the power of minus 2 into 2.5 into 10 to the power of minus 6. Already minus 2 plus minus 6 and it will be added up by getting the greater sign, greater number sign. Everything is same as that of first. But what they are doing in the division, this one will be divided but they will take up here. What will happen? See here, 10 to the power of minus 3. The denominator number is going to the numerator side. That time the plus 4 is get converted into minus 4. It will change to minus 4 here. Minus 3, minus 4, it will get minus 7. Again they are making to left minus sign only in a one number high. Okay. Till division you have to change the sign. Multiplication also you have understood. Next is addition. Significant rule for addition and subtraction. The result of addition or subtraction must be expressed with the same number of decimal places as term carrying the smallest number after decimal places. What they are telling means, after doing addition subtraction, you will be having various decimal places. Which is the smallest decimal place? Your result should bring to that smallest digital or decimal place. See here, 35.3, 3.53, 0.353, it will be equivalent to 39.183, a normal addition technique. How you will do? 35.3, 3.53, 0.353. How much you will get? 381.93 you will get. But which is the least decimal place? This is the least decimal place, right? After that, you will write here into 39.2. From the right side, which is the least? This one. See here, after 39, one digit, one decimal place. Same way, 4632.0, everything is added. Which is the least? One is the least. We have brought up for 5131.0, where the result is in the smallest digit in the question. You have to bring your answer to the decimal place, whichever least in your question. Next is subtraction. Subtraction also you have to do same thing with the same rule whatever you have seen in your addition. 583.35 minus 35.3. 1 is the least, you have to bring after 1. Similarly, the subtraction of two numbers can be done as shown below. 2.5 into 10 to the power of minus 2 minus 4.8 into 10 to the power of minus 3. What they will do? 2.5, 0.48. What they are doing means this term they are equalizing. Either it should be turned to minus 3 or it should be turned to minus 1. That's what they are doing here, conversion. 0.48 it will become minus 2. Then you can do 2.5 minus 0.48. You have to take it as common, this 10 power minus 2, then 2.02 into 10 to the power of minus 2. You should not multiply here. You should just take it, the exponent as a same. That's all. Okay. Next is precision versus accuracy. What is precision and accuracy? I have already told, whatever you will get the result, sometimes it will be precise or sometimes it will be accurate. Then what is the term? Means precision refers to the closeness of various measurements for the same quantity. Okay. If you have aimed for something, all the measurable or all the variables towards one side. It may be related to correct or wrong, but all the measured quantities are in one group. That is called precision. What is accurate? It is the agreement of a particular value to the true of the result. Okay. Whatever the skill value you have done before the experiment, that accurate level will match to that result or the observations. See here, high accuracy, high precision. The true value is here in between the goal or the aim. All the values are in one side, precise, and high accuracy also present. See here, low accuracy, high precision. The aim should be that the true value is present here. That's why low accuracy, but precision, all the measurements are closeness to one another. That's why it is precise. Here, high accuracy, low precision. Almost reaching the aim or the true value, but precision is low because little bit distance is there between the true values or the measurements. Low accuracy, low precision. Accurate true value is here, present true value is here. All the values are far to true value and the measurable trials also far. That's why it doesn't have precise value also, accurate value also. Another example we are seeing here with the data illustrated precision and accuracy. For example, the true value is 2 gram. Student A will get 1.95 at the first trial. For the second trial, he will get 1.93. At the average, what he will do? Average means 1 plus 2 divided by 2. That is number of individuals. Okay, 1.940 he will get. What student B? 1.94, 2.05, 1.995. Student C? 2.01, 1.99, 2 gram. See here, precise and not accurate because these two values are near to one another but not related to true value. That's why it is precise but not accurate. Student B, they are far to each other, the values are far to each other and not equivalent to or not near to true value. Not precise and not accurate. What is student C? Have got the measurement. It is near to one another and near to true value. That's why it will get precise and accurate. The values are precise also, accurate also. What you have to observe here means whenever you are doing the experiments, your answer should be precise as well as accurate. Whenever your answer is precise, not at all getting accurate, your marks will also get deducted as such only. That's why whatever result you will get in your experiment time, while doing the experiments, your answer should be precise as well as accurate to get a complete marks. Next is significant figures. Significant figures are meaningful digits which are known with certainty. All non-zero digits are significant. See, all the numbers we cannot tell it is significant. So, the significant figures are having some rules that how to follow we are seeing now. All non-zero digits are significant. See here no zero is only present in this number 285. For that reason, all the numbers are significant and 0.25 ml contains only 2 because non-zero only we have to take it as a significant, and also decimal is also present. Zeros preceding first non-zero digit are non-significant. So 0 indicates the position of decimal point. See here, 0.03 has only 1 because 0 preceding the first non-zero, and this decimal also represents the position of 0. That's why only 1 significant figure. Here also only 2 significant figure. Zeros between non-zero are significant. See here, non-zero, non-zero, in between 0. But all are significant only. Here also 1, 2, 3, 4, 5, 6. 6 significant figures. You have to understand, preceding 0 to the first non-zero are also significant. Zeros between the two non-zero is also significant. Zeros at the end or right of a number are significant provided they are not on the right side of the decimal point. Here, after the decimal to the non-zero, all are significant, 3 significant figures. But the terminal zeros are not significant if there is no decimal point. If there is no decimal point, this is also not at all significant. Okay. See here, only 1 significant figure, but 100 have 3 significant figures. 100.0 have 4. Such numbers are represented in scientific notation. Counting numbers of objects. 2 balls or 20 eggs have infinite significant figures as these exact numbers and can be represented by writing infinite numbers. After placing a decimal, that is 2 means it may be having more, 20 means it can be having more. Counting, you should see the first which is significant, later you should write the result. Next, how to do the rounding of the numbers. If the rightmost digit to be removed is more than 5, the preceding number is increased by 1. Okay. What are the rules? If the rightmost digit to be removed is more than 5, the rightmost is, we are removing, it is more than 5. Then it will increase by 1, the preceding. 8 is becoming plus 1, 9. If the rightmost digit is removed is less than 5, then the preceding number is not changed. See here, this 4 less than 5, that it will not change, 4.33 as such. If the rightmost digit to remove is 5, then the preceding number is not changed if it is an even number, but it is increased by 1 if it is an odd number. It is 5, but the behind number is odd, that's why it is getting plus 1. If it is even, it will not get plus 1, it will be as same. These are the rules of rounding of the numbers. Once again, next to the last digit, if you want to remove, it will be more than 5 means it has to be plus 1. And the rightmost, if less than 5 means it cannot change. And the preceding, the removable number is correct for 5 and the preceding one is odd, then it will be increased by 1 unit. If it is even, it will not increase, it is remain as such. And in the next class, we will discuss about dimensional analysis, laws of chemical combination, atomic mass, molecular mass and formula mass. I hope you have understood whatever I have taught in these sessions. So, for the further videos, keep on watching our channel. Thank you.